All right, guys, let's go ahead and get started since we are now recording. As you guys know, today we're starting a new 6 weeks period. Um, we're nearing the end. So this is the final 6 weeks of the year. The end of the school year is rapidly approaching. Today is going to be a pretty straightforward day. I'm just going to introduce electrical circuits. We're going to talk a little bit about circuits, the concepts. There's not going to be any math today. Just focusing on you guys understanding the introductory material to circuits. Let me go ahead and share my screen. So we are still on our topic of electricity. Remember, we started electricity about a week and a half ago. This is fifth period. Click on the materials tab. And if you click on the materials tab, you will notice that there's a new folder that I put in the material or under the materials tab, which says final 6 weeks. So if you click on that and you click on the week of April the 26th to the 30th, because today's the 27th and it is a Tuesday, you guys will see the electrical circuits assignment already opened and available for you all. What I'm going to do, I'm going to discuss a few things with you guys, and a few of these questions we're going to do together. So this day should be very easy for you all, really easy, because we're going to do most of the assignment together in class. Okay. Before we get started on the assignment, let me review a few things that we talked about on last week. So remember how I showed you guys this video whenever we were talking about electrical charges. So I showed you guys this video here of this girl combing her hair. Remember I said as she combs her hair, there are electrons being deposited from her hair to the comb because of friction, right? So, so as she places the comb near a stream of water, notice what happens. The water bends. So the question is, why is the water bending? Well, what is causing this bending effect? Well, remember what I said last time. As the comb gained electrons, guess what? The comb acquired an overall negative charge, and those negative charges attracted the positive charges that exist on the water molecule. Okay, so remember what I said last time. Opposites attract. Anytime you take a positively charged object and you place it next to a negatively charged object, they're going to attract each other. That's what's going on here. You guys clearly see the water is being attracted toward the cone. Clearly. So remember, opposites attract, like charges repel. That is the most important thing you guys need to remember from our introduction on last week to static electricity. I'm going to say it again. Opposite charges attract one another, like charges repel one another. Super, super important. Okay. So with that said, we're ready to take this concept and extend it further into electrical circuits. Okay, so let me open up this PowerPoint here. So let's talk about how we are able to create an electrical circuit. So guys, imagine here that you all have a battery. You guys are familiar with batteries. You've seen batteries before. Remember, all batteries have a negative side and a positive side. It is true of all batteries. They have a negative side and a positive side. Now, imagine that I take a copper wire and I connect it to this battery. Okay, remember, a copper wire is a conductor. Remember what we said about conductors. Conductors are excellent at causing electrons to flow through the material. In other words, they conduct electricity, hence the name. Okay, so there are electrons all over this copper wire, right? This copper wire is made up of a lot of electrons. So guys, it should be obvious to you all that if I connect this copper wire to this battery, remember, like charges repel each other. So it should be obvious to you guys that the electrons are going to be repelled from the negative end, and they're going to be attracted toward the positive end. And that's exactly what happens. In fact, that's one of the reasons why we have an electrical circuit. Because these electrons are flowing, they're being repelled by the negative end, and they're being attracted toward the positive end. So everybody got that? So that's what an electrical circuit looks like. It's just nothing but the flow of electrons um, away from the negative end toward the positive end. And like I said, of course, I'm just showing you guys one electron, but in reality, there are multiple electrons, many electrons all over this copper wire, and all of those electrons are being repelled from the negative end, and they are being attracted toward the positive end. So everybody got that? So that's a little introduction to electrical circuits. Now let us get into the details of those things that are required to maintain charge flow across an electrical circuit. So let me go ahead and pull up Kami so I can begin by annotating the page. Okay, so guys, and I want you guys to help me out here as we answer these 4 questions. Again, we're just going to do a little bit of this before we get to the assignment. So what this says here, to maintain a charge flow in an electrical circuit, at least 2 requirements must be met. 1, there must be some sort of external energy supply, such as a battery or a generator or something like that. So there must be an external energy supply to pump charge through the internal circuit and establish a potential difference across the circuit. 2, the external circuit must make up a closed conducting loop between the positive and negative terminals. Okay, so there must be a closed conducting loop. Everybody got that? Okay. Utilize your understanding of these requirements to state where the charge flow will flow through the following circuits. If there's no charge flow, then explain why not. Okay, guys, look at this first diagram here. We're going to go through each of these 4 diagrams. So notice here I have a battery, I have a copper wire, and here there's a switch connected to the copper wire, right? The switch can be open and it can be open and closed, so there's a switch. And also there's a light bulb connected to this copper wire. Let me ask you guys a question. This first diagram, according to what you guys see here, would there be a charge flow? Would there be a flow of electrons from the negative end toward the positive end? In other words, will this light bulb light up? Yes or no? Anybody want to tell me? You either want to tell me in the chat box or unmute yourselves. So yes or no, will there be a charge flow? Are both requirements met here? Okay, someone sent me a private message and said, someone said no, and then the other person said yes. So I'm getting 2 different answers. Guys, if you said no, you are correct. There will not be any charge flow. Guys, give me just a second. There's someone at my door. Okay, so the answer is no. And guys, the reason why it is no should be obvious to y'all. Remember what I said, that in order to have an electrical circuit, there must be a closed conducting loop. This is not a closed conducting loop. Notice the circuit here is open. The loop is not closed. Okay. Um, what about this situation right here, guys? If I have a battery here and I have a copper wire connected to the negative end, will I have charge flow here? Yes or no? What do y'all think? Okay, the person that answered me properly, yes, it is no. Okay. And it should be obvious why it's no, because notice what requirement 2 says: the closed conducting loop must be between the positive and the negative terminals. Notice this wire is only connected to the negative end. One end has to be connected to the negative, the other end has to be connected to the positive. Um, what about this situation right here? Will we have charge flow? Yes or no? What do y'all think? Will the electrons flow here? Okay. So thank you for that answer. Uh, the answer is yes, there will be charge flow here, because notice both requirements are met. We have a battery and we have a closed conducting loop between the negative terminal and the positive terminal. So therefore, the electrons are going to flow from this end toward that end, and the light bulb will light up. Okay. This last one here, some students get tricked up here. Will there be charge flow here? Yes or no? The answer to this question here is actually no. Um, now, guys, if you wanted to achieve charge flow here, what you would have to do here, you would have to take one of these batteries and you would have to turn it around. Um, you would have to take one of the batteries and you would have to turn it around. Like, in other words, if you take one of the batteries and you flip it like this, so if you take the battery and you flip it such that this is now the positive end and this is the negative end, then you would get charge to flow, right? Because the electrons the electrons are repelled from the negative end, they're being drawn toward the positive end, okay? And of course they're pumped across the battery, and then there's electrons here that are being repelled by the negative end and then drawn toward the positive end. Okay, so then they're being pumped across here, then they're repelled by the negative end and drawn toward the positive end, and so you're just going to get a flow that just continuously go like that. Okay, so okay, now before we look at that assignment, there's one more thing I want to talk to you guys about in terms of convention. You know what? Let me do this here. Let me open this up in Kami. Okay, so in Kami, I just want to go over with you guys several important terms that you guys could see throughout this unit. I'm just going to kind of introduce these terms to you all, and we're going to talk more about these terms in the coming days. So here is a battery here, and connected to this battery is a wire, thereby creating a circuit. So guys, you can use a voltmeter and use this voltmeter to touch these terminals in order to measure voltage. That's what a voltmeter does. It measures the voltage of the battery. An ammeter, basically, it's a device that is used to measure the flow of current, like how much current is flowing through this wire. And lastly, this device right here, this is what is known as a resistor. Guys, what resistors do is exactly what they sound like. Resistors resist the flow of electricity. Guys, people who design circuits and electrical equipment, they use resistors to control the flow of electricity in such a way that it will enable the device to function properly. So resistors are used to control the flow of electricity. They resist the flow of electricity, so they kind of slow current down, if you can think of it that way. Guys, typically in physics, whenever you guys see a circuit diagram, I just want you guys to know that on circuit diagrams, a lot of textbooks have the habit of drawing squiggly lines here to represent resistors. So anytime you see a circuit diagram and you see a squiggly line that looks like this, that squiggly line is a resistor, right? So that just tells you that somewhere in the circuit, right at that, at that point in the circuit, there's a resistor in the circuit. Okay, so just keep that in mind. So this is how we draw resistors. Another thing I want to go over with you guys in terms of convention. Sometimes some textbooks will draw circuit diagrams like this. Let me kind of show you guys here. They might draw a circuit diagram like this. Like this. Okay, sometimes you can see a circuit diagram like this in a textbook. Guys, if you see a circuit diagram right here, these two lines right here represent the location of our battery in the circuit. Typically, guys, the longer line represents the positive end, and the shorter line represents the negative end. So this tells us the location of a battery in our circuit, and obviously, there's a flow of electrons going through the circuit. Remember what I said, anytime you see these squiggly lines right here represents a resistor in the circuit. So resistor are devices that they slow the flow of electricity. They resist the flow of electricity. And again, these are used to control electricity, which is very useful for the functioning of certain devices. Okay? And again, we're going to elaborate more on these concepts in the coming days, elaborate more on these terms. I just want you guys to be familiar with the diagrams whenever you guys see them. All right, guys. With that said, let us close the day today by doing a few of the questions on the assignment. So, guys, if you are at your computer right now and you are in Schoology, go ahead and open up the assignment right here that says electrical circuits. So go ahead and open that up. So hit preview. Okay, so start new assignment. So look, we're just going to go over a few of these as a class. Well, most of them as a class we're going to go over. Where it says define an electrical circuit. I'm sorry, not define an electrical circuit, but define a circuit diagram. So guys, I just showed you guys a moment ago a circuit diagram. A circuit diagram is basically a shorthand way of drawing electrical circuits. Okay, so that's what a circuit diagram is. It's a shorthand way of drawing electrical circuits. So again, guys, scroll to this question right here and go ahead and answer it. Which of the following are correct? There may be more than one right answer. Okay. So guys, remember what I said, in a circuit diagram, the two lines show us the location of the battery. Remember what I said, the longer line tends to be the positive end, and the shorter line tends to be the negative end. So can y'all tell me which answer choices will apply? A, B, C, D, or is it a combination of two answer choices, a combination of three answer choices? Which one? Anyone want to tell me in the chat box? Yes, Trinicia, it is B and C, right? Because if you notice, these here, the longer end is positive and the shorter end is negative. So these two diagrams are correct. B and C. Thank you, Trinicia. Okay, so label the diagram here. So guys, we have a simple circuit diagram. Let's label each of these components. Let's start with A. Remember what I said? It's, even anytime you see this squiggly line here, that represents a resistor. That represents a resistor. So, A is our resistor. What is B? Remember I said these two lines right here represents the position of the battery in the circuit. So B would be our battery. Okay. What is C? Okay, so that looks like they're showing us the position of a light bulb. So C is the light bulb. Okay. If you look at D is pointing to the wire itself. So D is the wire. Okay. And you notice E points to a switch. Remember, switch is the location where we're able to close and open the circuit, right? It can be open and close, open and close. So E is the location of a switch. Okay. So y'all got that? Okay, let's keep going. What is the definition of an open circuit? We talked about this. An open circuit is a circuit with a break in it. Electricity won't flow. An open circuit is a circuit with a break in it. Electricity won't flow. Okay. So, um, with that said, guys, you guys should immediately know what a closed circuit is. So you guys should know what a closed circuit is. So I'm gonna let you guys answer that one on your own. The last one I want to talk about today, where it says match the words with this description. Okay. So let's start with wires. What are wires? Wires allows electricity to flow, right? Because wires are made up of copper, meaning that they are excellent conductors. They allow electricity to flow. Batteries, um, batteries push electricity through the circuit. Basically, they supply the potential difference for the circuit. Okay. A resistor, we've already talked about what a resistor does. Um, um, we know what a light bulb is. A light bulb is used to create radiant energy. In other words, a light bulb um, um, is exactly what it sounds like. It creates light, and that's what light is. It's electromagnetic waves spreading outward. So basically, what's going on is that the electrons, as they uh, slam into the light bulb, they cause those atoms to jiggle, and they jiggle at such a rate that they create electromagnetic waves outward. And those electromagnetic waves is what gives us light. It's radiant energy. Okay. Um, so guys, go ahead and just finish the rest on your own. We've done most of them. Are there any questions for me? Guys, if you have not filled out the attendance form, please go ahead and do so at this moment. If there are no immediate questions for me at the moment, you guys are free to go. The Zoom call will stay open up to 9 o'clock if you need me. Have a good day, everyone.
Bruh.
All right, take it easy, guys.